All right, students, today we're going to talk about how to find the area of a trapezoid and a kite. And before we do that, we're going to review a couple of formulas that we have already learned that we're going to need today. So, what we're going to review is how do we find the area of a rectangle, and we remember that that is a base times a height. The base and the height have to always be at 90 degrees to each other. That means they have to make a square corner. Okay? So to find the area of any rectangle, you're going to multiply a length times a width, or we're going to call it a base times a height. Okay, then after that, we investigated triangles, and we found out that if this triangle right here was a rectangle, if it came on out like this, and we put a diagonal in there, then this would be half the area of a rectangle. So here's our rectangle area, and then we put a half in front of it. And it's the same is true for any shape triangle. The formula comes out to be the same. Whether it is a right triangle, an obtuse triangle, or an acute triangle, it doesn't matter. The formula is the same. We just have to locate the base and the height. This one's easy because they come together right here. On this one, the base is going to go all the way across here, and the height is going to be 90 degrees to that. The height is not going to be one of the sides of the triangle. On this one, my height is actually can be located outside the triangle because it's got to be perpendicular to the base. So if I call this the base, then this has to be my height. Okay, if I call this the base over here, then my height would be in here like this. Okay, so the base and the height, the small b, the small h, stands for base and height. We always use lowercase letters for that, and they always have to be at 90 degrees to each other. So don't forget any of that. Now let's start today's lesson on trapezoids and kites. Now, there are some different types of trapezoids. There's a right trapezoid, there's a scalene trapezoid, there's an isosceles trapezoid. And I want to show you what those are right quick. So, just a moment. Okay, here's the three different types of trapezoids. First of all, a trapezoid has four sides, and it has one pair of parallel sides. See these little arrows right here? It's saying that this side is parallel to this side, meaning it's the same distance apart all the way across like railroad tracks. In this trapezoid, this pair of sides is parallel, and in this trapezoid, this pair of sides is parallel. So a trapezoid has four sides. It has four sides. It has one pair of parallel sides. Okay? And then we're going to identify the different types of trapezoid. Okay, well, these two sides don't match, so this one is called a scalene trapezoid. Or in some textbooks it calls it an irregular trapezoid. That's another way of saying that those two other sides don't match. This one is called a right trapezoid because it has two right angles in it. This side straight and this side slanted. Okay? This one right here is called an isosceles trapezoid because this pair is parallel, but these are equal in length. So what we could do on this one right here, we could drop a height down right there, and guess what we have? We have a rectangle and we have two triangles. We could find the area of this one, we could find the area of these two and add all three up, and we'd have the area. On this one, if we drop this right here, we have a rectangle and one triangle, so we could find the area of this, and add them together. And then on this one, if we drop these perpendicular right here, we have two triangles again, but they're not the same size. So we have to find this one separately, and this one separately. So we'd find a rectangle and a small triangle and a medium-sized triangle. Over here, if we found this rectangle in one of these, we could just double this one because these two are going to match. So what you need to understand is a trapezoid is a four-sided figure. It's got one pair of parallel sides, and that's about all the properties it's got. Because then depending on how it's drawn, which kind of trapezoid it is. Oh, and by the way, this one is called a regular trapezoid, where this one was called irregular. This one's called regular. These two side lengths don't match in this one, and they do match in this one. Okay, so now you know what a trapezoid is. All right, well, I wonder what a kite looks like. I don't know if all of you have flown a kite before, but I'm going to draw you a picture of a kite. Give me just a second. Okay, so here is a kite, and if you notice, on a kite, these two side lengths right here match. They're the same length, and these two right here are the same length. But these are not the same length as that. They can't be, or it's not a kite. So what do we notice here? Well, we have four sides again. We have nothing parallel, nothing like that. No sides. I have two pair of equal sides. Two pair of equal sides. And that's about all you need to know for now. There's some other properties, but we're not going to discuss those right now. But what you need to be able to see is that if I were to draw a line right across here, I'd have two triangles. And if I could find the area of that triangle and the area of that triangle, then I would be able to find the area of the whole thing by adding those together. So when I'm working with a kite right now in the 6th grade, this is going to end up being my base, and they're going to have to tell me that little length right there and that length right there. Okay? So this little dotted line across here will be my base, and then that will be the height of the little triangle, and this is still my base, and then this will be the height of the other triangle. And that's how we're going to split these apart to find areas. Okay, well there's a good preview of what we're going to do, so get ready. You need pages 413 in your book, 413 through 417. And once again, we're going to find the area of trapezoids and kites. And let's see what they're going to do here on the Explain It. The European basketball key was changed from a trapezoid shape to a rectangle in 2010. The diagram shows the shape of the key before 2010 outlined in blue. Okay, so you see that this right here is 6 and this is 3.6. So there's your trapezoid right there. Okay, let's go down here and see what it wants us to find. Tim finds the area of the key by multiplying the base by the height. Does his strategy make sense? Okay, let's go back and read. The European basketball key was changed from a trapezoid to a rectangle. Diagram shows the shape of the key before 2010 was outlined in blue. Tim finds the area of the key by multiplying the base times the height. Can he do that? No, we can't do that because it's not a rectangle. Okay, so let's redraw it right here. It actually looks like this, which is a trapezoid. This is 3.6 and this is 6. Okay, so this is, if I call this the base, my height is off out here somewhere because my height has got to be perpendicular to my base. Everybody knows perpendicular means at right angles. Agreed? So if I take 6 and subtract off 3.6, what do we get? Use your calculators. It should be 2.4. 6 minus 3.6 is 2.4. So we get 2.4. Now if I cut that in half, 2.4 cut in half. This is going to be a 1.2, this little dotted line. And this is going to be a 1.2 because all three of these numbers have to add up to 6. Okay, so there's where I got the 1.2. Now, this whole rectangle is a 6 times 5.8 because they told me this dotted line right here was 5.8. But what's the shape of the trapezoid? The trapezoid is the rectangle minus the two triangles. So the answer is no. Does his strategy make sense? No. The answer would be the area of the rectangle minus the area of the two triangles. Okay? Now, over here in part B, it asks us, well, how could Tim find the area? Well, we just said it. We said it right here. And then it says, what is the area of the key? So we want to go find the area of this trapezoid. So here's our strategy. The area of the TRAP, trapezoid, and I usually abbreviate like that, is the area of the rectangle. I'm going to make a little schematic right here, and you need to do this with me. And then we're going to subtract off the area of a triangle and subtract off the area of the other triangle. So we're going to take off two triangles from this rectangular area. Well, the rectangular area is easy. It's 6 times 5.8. It's 6 times 5.8. I'm going to use parentheses. I don't like the dot when I've got decimals in there. And then I'm going to subtract off, and please, I hope you understand what I'm doing. I'm going to subtract off 2, because there's 2 of them, and they're the same size, 2 area of the triangles. Well, the area of the triangle is a half times a base of 6, times a base of 1.2. See, the triangle right here has got a base of 1.2 and a height of 5.8. So times a 1.2 times a 5.8. Base and heights have to be perpendicular to each other, and I'm doing this one. And the 2 right here gets both of them at the same time. So I have 2 1/2 base times height. Now, because you've been blessed with a calculator recently, we're going to do this on our calculator. We're going to say 6 times 5.8. But you're not going to do anything on that calculator until you have written down what you plan to do. You always write down the plan. Okay? And then I get 34.8 minus, now look here with me a minute. What's 2 times a half? Isn't that just 1? So don't bother punching all that stuff in there, because 2 halves is 1. And 1 times anything is the anything. So all we really have to punch in is the 1.2 times the 5.8. So 1.2 times 5.8 is 6.96. Okay, now we need to subtract these triangles off this rectangle and we will have the trapezoid. So we're going to put back in the 34.8 and subtract off the 6.96. And we get 27.84. It was meters, so it should be meters squared because area is always in square meters. Or square units, not meters every time. Okay. I think you're getting the idea that even though it's a new shape, we have old formulas that's going to help us find our answers. Let's go down here to focus on math practices. How can you find the area of this kite? Well, I've talked about that just a little bit before we started working on this lesson. So we're going to break this up into two triangles. And I see that this piece right here, from here to here is 3. So from here to here would be 6. Because they told me this is 3 and this is 3. So I have a triangle that's 6. And this height is 4. And then I've got this triangle that looks like this down on the bottom. This is still 6. And this height is 8. Okay, so we're going to take area of the kite is going to be 1/2 times 4 times 6 plus 1/2 times 6 times 8. This triangle plus this triangle. Well, multiplication fact says that 4 times 6 is 24 and half of 24 is 12, so that comes out to be 12. And this is, you can do it any order you want to. Half of 6 is 3 and 3 times 8 is 24, or 6 times 8 is 48 and half of 48 is 24, but anyway you get 24. And 24 plus 12 is 36, so our answer is 36 feet squared for the area of the kite. And it's that easy. What makes it easy is when you understand the formulas and you understand what the letters in the formulas mean, and that a small lowercase b is base and a small lowercase h is height, and they have to be at right angles to each other. Okay. Turn the page. Example 1. I am not doing with you. It's done for you. All you have to do is read through that on your own. Teachers, I would expect that you would read through this with them. If you want to pause the video and do that, I'm going to the try it. The try it looks like a trapezoid. We're going to identify the trapezoid. Well, it is a right trapezoid because it's got two right angles down here. And here's my set of parallel sides. You might as well be learning all this right now. Okay, so if I make a rectangle, bring this straight across. Now I've got two more right angles, so this is a rectangle, R-E-C-T, and this is a triangle, T-R-I, and we're going to find the area of the triangle. The area of the trapezoid is going to be the area of the triangle plus the area of the rectangle. That's our plan. Well, let's do the triangle first, since I put it in there first. I need a base and I need a height. My base has got to be this. My height has got to be, here's my base and this is my height. Well, I don't have a number right here, but I do know that this whole side is 11.25 and this side is 6.25. So if I subtracted those, it would be 6.25 up to here, and the rest of it would go from here to here. So that's a 0 and a 0, and 6 from 11 is 5. So this height right here has got to be 5. So I need this base, which is the same as this number down here. I need 1/2 the base of 5 times the height of 5. It's got a base of 5, it's got a height of 5, and my formula says for a triangle is 1/2 the base times the height. We'll finish that in a minute. Our rectangle is a base times a height. So it's a 5 times a 6.25. Once again, you've been blessed with calculators to use. It makes our life go a little faster, because right now this is supposed to be the hard part, is getting all this set up. This becomes the easy part. So here, clear your calculators a couple of times, and let's put in, how do you put in a half in your calculator? Real easy. 0.5. Everybody should know that by now. 0.5, decimal 5, 5/10 is the same as a half. So 0.5 times 5 times 5 is 12.5. 12.5. And then we have clear calculators. We got 5 times 6.25. And we have 31.25. 31.25. So let's clear our calculators and let's add that together to get our total. We need 12.5 plus 31.25, and I get 43.75. And of course you can do all this by hand if you choose to. You can do it all by hand. If it's on the calculator portion of the test, then use your calculator. Okay. Oh, we're moving on because it's taking a while today. We're going to go on to example 2. Talk about it. Example 2, find the area of a different trapezoid. Well, this is like one I showed you. This is an irregular or a scalene trapezoid. No sides are equal. And you're going to do the same thing, except you can't just double these areas because this triangle does not match this triangle. This one's a smaller one, this is a bigger one. So, you're going to have, they split it apart for you over here. You're going to have triangle A, which is 1/2 times 4 times 5. That's this one right here. Then they're going to do the rectangle in the middle. And I wish they wouldn't use length times width. I wish they would continue to use base times height. So, when I do rectangle, I'm going to say a base times a height. And then this one over here is your little triangle. It's a 1/2 times a 2 times a 5. And then we're going to add all that up. Okay, so that's all I'm going to do about that. Go to example 3. A kite is a quadrilateral. Oh, I haven't used that word. Quadrilateral means 4 sides. Quadrilateral means 4 sides. Please know that. Trapezoids are quadrilaterals. Rectangles are quadrilaterals. Squares are quadrilaterals. Rhombuses are quadrilaterals. A triangle is not a quadrilateral. Quadrilateral means 4 sides. So if I ask you in class one day to name all the quadrilaterals you can, you got to know you're looking for something with 4 sides, and that's it. Then we have specific kinds of quadrilaterals. In this case, we have a kite. Now, a kite has 2 pair of adjacent. Now, this is a very good word. Adjacent means next to. If Susie is sitting adjacent to Tommy, they are sitting side by side or front and back of each other. They're next to each other. Okay? So this pair right here is a pair of adjacent sides. This is a pair of adjacent sides. This is a pair of adjacent sides. Okay? But notice what it says. A kite is a 4-sided figure with 2 pair of adjacent sides that are equal in length. So it's this pair I'm talking about and this pair I'm talking about. Now, it doesn't mean that these 2 are not adjacent. They are, but they're not equal in length. These 2 are adjacent, meaning next to. See that vertex right there? This is called a vertex. This is called a vertex and a vertex and a vertex. There are 4 vertices. V-E-R-T-I-C-E-S is plural for vertex. There are 4 vertices on a 4-sided figure. There are 4 vertices on any quadrilateral. Okay, so how are they going to break this apart? Well, they're going to break it apart into 2 triangles. They could either do this triangle like this and this one like this and call this the base and this the height, or they can break it apart right here and call this the base and this little piece the height and this the base and this little piece the height. There's 2 different ways to go about this, and they do this one for you right here, so I'm not going to. So go to the try it. Find the area of the trapezoid and the area of the kite. Okay, well, our first job is the trapezoid, so we're going to go here and we're going to see if these 2 side lengths match. Okay, this is 12 and this is 4, so 12 and 4 added together gets me to right here. 12, this 12, and this 4 is 16. That leaves this to be a 4 over here also. So these triangles match. Okay? So this is a regular or an isosceles trapezoid. Okay. So I need to find the rectangle and these 2 triangles and add them together. Well, let's do the rectangle first. I'm going to find the area of the trapezoid by finding the area of the rectangle and the area of 2 and 2 times the area of the triangle because they match. Okay, area of the rectangle is base 12 times the height of 8. So we have area is 12 times 8 plus 2 triangles, so it's 1/2 the base of 4 times the height of 8. 4 times 8. Do you see where I'm getting the base of 4? Because I'm neglecting everything else and I'm looking at this triangle. So here would be my right angle right here, and this is my base, and this becomes my height. Okay, and I have 2 of them. All right, it is calculator time. Thank goodness, saves us a lot of time. I need 12 times 8, should know what that is. 96. Okay, once again, 2 times 1/2, that's just gone because that's a 1. And then I need 8 times 4 is 32. So my area total is 96 plus 32 for a grand total of 128. Get your units on there, centimeters squared. And that's how easy that is. We're going to use shapes we already know to work on a new shape. Our new shapes are trapezoids and kites. Okay. This time, I'm going to do it differently. I'm going to, let me highlight this. I'm going to find the area of this triangle and double it. So this becomes my base and the 3 becomes my height. So I have the area of the kite is going to be 2 times the area of the triangle, because this triangle is going to match this one down here. And let me do it in blue. See that? So I need 2 times 1/2 times the base of 10, see it's 10, or 6 plus 4 is 10, times the height of 3. 1/2 the base times the height, and I have 2 of them. Once again, this is going to cancel. 10 times 3 is 30, so it's 30 inches squared for the total area. Okay. Turn your paper over, page 416. There's a really good review of what we did in this lesson right here. Teachers, this video is getting quite lengthy for this lesson, but I really think they're getting it. They just have to know how to find the area of a rectangle, how to find the area of a triangle, and how to locate the base and the height on any shape that they're needing to find the area of. So, their job today is to work through the do you understand, the do you know, and the practice problem solving. You have some other papers. You have a vocabulary paper, and you have a quiz over this. Use whatever materials you choose to use, but take some time and work through these problems. I think they'll find this is not so bad once they get started. But make sure, students, you always write down the formulas that you're going to use, then put the numbers into those formulas, and then last but not least is when you pick up your calculator. Let me set up number 4 and show you what I mean. Find the area of each. So here's my plan. The area of the trapezoid, the trap, is the area of the rectangle plus the area of one triangle. You write this plan down. Then you put the formulas into your plan. So the area is going to be a base times a height plus a 1/2 base times a height. Now you have to go locate these B's and H's, the correct ones. So the rectangle is going to be a base times a height. Well, what is this base? It's written right here. It's the same as this. So it's an 8. So it's going to be a base times a height. My 1/2 goes in my formula. I need a base and a height. Well, it's an 8 and it's a 6. Because this 6 is only this little piece right here. Because you know this is a 12 right up to here. So it's an 8 base and a 6 of height. Last thing you do is pick up your calculator and punch that in to get your answer. So on every problem like this, you start with a plan. You put your formulas into your plan. You put your numbers into your formulas. And then you pick up your calculator and punch it in. It's very important that you put these steps in there so you don't get lost as to where you are. Okay, good job, and I'll see you next time. Trapezoids and kites.